unfortunately, I didn't prepare on English language my presentation, but I will say something, and because I have 6 minutes.
Yes.
Okay, that will be very easy to explain. I'm president of National Organization for Fire Protection Serbia, and we are in Confederation Fire Protection Europe. You see the members of the Europe on this, and we are also in at CFPA Confederation International, and in this international confederation it is 52 lands around the world. Between these lands it is America, it is Australia, Kenya, and Indonesia, 52. Okay, I cut my complete explanation on the 3 pieces very shortly. You will see that will be very good for you. You will see the film. It's a film, it is from Brazil. It is fire in Brazil high-rise building. And you will see the transport from fire with windows, between windows. You see the climatization part, and start the fire with the windows. We have possibility now, when we have a system of the transport fire with the windows, we have a possibility, very good possibility, to make the calculation exactly to stop, to jump the fire between windows. That's very interesting. I'm 10 years later, I was in Sao Paulo, and I see this house. It is this high-rise building. It is reconstructed, but nobody it is in. Something it is very interesting in this high-rise building. It is many 100 people is dead in this building because of this fire. This is a reconstruction building 10 years later. Okay, I will show you now we have possibility to make the calculation to stop the jumping the fire from one window to another window. And I go very fast to this presentation, because this presentation it is for 3 hours.
Thank you very much.
Okay, it is, and I go a little bit. You have here possibility the thermodynamic uncontrolled combustion to see, and you must know the uncontrolled combustion, because with uncontrolled combustion you have a possibility to see the jumping of fire between windows. This whole presentation, it is very fast. You see, in 3 minutes. That's very interesting. It is, I make many years ago software for transport of energy in fire. And this software, it was the first one on the world. And I go on. Now we have a possibility how jump the fire between windows. And I show you that's the calculation how we can know exactly the distance between the windows. Who is interested? I can say in April we have in our round we have, now we start with second part. Now the material on the outside of the high-rise building or building can be problem to burn the house. You will see now that's 2012 in Roubaix in France. One building, it is in 15 minutes the fire it is going up with material, it was very bad. And it is without testing. Now we have very good contact with many labors around the world. With English labor, LPC, they make some experiment. Also VDS in Germany, they make also experiment. And we have all the time the contact with the CFPA, Confederation Fire Protection Europe, and we can testing the materials. Okay, we go, I stop. Now we have also possibility to control the material on the houses. You have here you have exactly all diagrams to make the control. That's international European. That's a European standard for the control of materials. You have all this control, but it is something. Something happened. They try with a very bad material. You see very bad material here. Without testing, and they try to stop the fire with rock wool or some other material to don't jump between the windows. You see here the possibility to stop the fire between the windows. But experiment in CMPP in France, they show us that this system now it is not possible. Our standard in Serbia, it is changed in last time, and this material to stop the fire, it was 20 centimeter, it is nothing. And in the last moment in our standard, it is 1 meter must be. But with the experiment we do in laboratory in France, CMPP, we found that this distance and the fire from the material must be more than 1 meter. Now at the last I let you the houses with windows houses. For 10 years ago we tested the windows fire in a laboratory at LPC in England, and they made a completely system to testing what's happened when fires jump between windows in one such a house. It is very interesting. We have a very good contact with insurance companies, and many of these experiments it is paid from insurance companies.
In 1991, they found a serious fire developing, with flames already penetrating the curtain wall. The floors of the building were designed to be resistant to fire and did their job. So what caused the fire to spread so dramatically? Heat and smoke travelled through an unstopped service duct and up the curtain wall of the building. 46 fire appliances and 176 high-rise buildings. It was clearly time something was done about the problem. In this series of experiments by LPC scientists, a 3-floor section of full-scale
meters in height and 6.5 meters wide. This allows us to have 2 complete scale floors on which to perform fire tests. It also allows us to have an underfloor area 2 meters high to build fires such as this one to evaluate fire breaking through curtain warning systems from the exterior. The rig is instrumented to shorten minutes.
Okay, I was in this time in the LPC Labor. And we have many more data than you see now. At the end, because we expert for fire protection, we have all the time a problem with architects, with many other engineers. I say we are like Don Quixote, and at the end I let you Don Quixote to see. it is very interesting. This Don Quixote, I make the film from Don Quixote in Madrid, and it was a General Assembly of Confederation Europe, and it is very interesting. I stop and I make the film, and I said, I'm filming all the time like Don Quixote with this problem with fire protection. And he said, from where you are? I said, from Serbia. I'm from Croatia.